Bismillah ar-Rahman ar-Rahim. Assalamu alaikum. This is Dr. Ahmad Al Faris. Today we're going to answer M1 Edexcel, October, November 2019, according to the new syllabus. As you know, we usually have 7-8 questions: momentum, pulleys, vector, 1 or 2 questions, inclined plane, and a question about graphs. Usually these questions, they start from warming up questions. Okay, the first 3 questions, they will be easy. Okay, and the last 2 or 3 questions, they take a long time and it will be hard. So we are going to take advantage of using the first 3 questions, okay, because they are easy, to try to answer them as fast as we can, to use the time to answer to use this time to answer the last 2 or 3 questions. Okay, let's start from the beginning. Bismillah ar-Rahman ar-Rahim. 2 particles P and Q of masses 3m and 2m respectively. Okay, this is 3m, this is P, and this is 2m, this is Q. Okay, the particles are connected, okay, by light and extension string. Initially PQ are at rest. Okay, we have a light and extension string, okay, like this. Okay, with the string was slack. Okay, the particle P then projected along a plane weight directly away from Q with a speed of 4u, so it moves in this direction, 4u. Okay, and at the same instant, particle PQ is projected along the plane in the direction opposite. Okay, with a speed of what, 3u. Okay, like this. Okay, find the common speed for both particles when the string becomes taut. Now, when the string becomes taut, both particles, they are one object, one body. So according to the table that we usually do, okay, P, Q, M, U, V. So here 3m, here 2m. Here it's for the left, negative 4u. Here it's to the right, 3u. Okay, and they ask about both speed together. This is part A of the question. So we are going to use the long formula that total momentum before equal total momentum after. So mu plus mu for P for Q is equal to m plus m v, because they become one body. Okay, for P and for Q, they ask about this v. Okay, so let's substitute the values here. 3m multiplied by negative 4u plus 2m multiplied by 3u, it's equal to 3m plus 2m multiplied by v, that we want to find it out. We can cancel m with m, so we will get negative 12u plus 6u equal 5v. So v divided by 5 divided by 5, it will be what? Negative 6u over 5. The negative here means to the left. Okay, so they didn't ask about the velocity, they ask about the speed. So the speed for both of them, it will be 6u divided by 5. Okay, good. Any question here? Is it clear? Let's move on to the next part. Yeah. Part B, the magnitude of the impulse exerted on Q, okay, at the instant that the string becomes taut. Now we know that the impulse is equal to mv minus u, for whom? For Q, for Q, for Q. So the mass for Q, which is what, 2m, multiplied by v, which is negative 6u divided by 5, minus the initial speed for Q, which is 3u, and by using calculator, okay, we add, this will be 15u over 5, okay, minus 6u over 5, okay, all of this multiplied by 2m, and the final answer will be negative 42 mu divided by what, m. And since they ask about the magnitude, so the magnitude of the impulse, I will not put the negative sign, it's 42 mu divided by 5. Any question? Is it clear?
Yes, clear لحد الآن.
Alhamdulillah. So as you can see here, it's 3 plus 3, 6 marks. That means 7.5 minutes. We did it in a few minutes with explanation. You can do it faster than me if you practice well during the exam. Let's go to question number 2 here. What do we have? A small ball, okay, is released from rest. The initial speed is 0, okay, from a point which is 40 meters above the horizontal ground. The ball bounces on the ground and rebounces vertically. Each time the ball bounces from the ground, the speed of the ball, okay, is instantaneously reduced by how much? 50%. So half the velocity of impact, it will be the initial velocity of bouncing, okay? I will explain it now again. The ball is modeled as particle and freely under gravity from the instant when it released to the first instant that it hits the ground and between the successive bounces. Okay, part A, find the time from the instant it falls and released from rest to the instant when it hit the ground and the second time. Okay, so this is the height from here to here to the ground. This is the height that it released from, it's 40 meters, okay, and it falls from here, okay, no dimension, no second dimension, but I would draw it like this. It falls like this, hits here, and bounces like this, and hits here, etc. Now, they tell us, what do they tell us? That u here initially, it's equal to 0, and v here finally, it's unknown, but it's the u here in the second situation as it bounced back, okay, it's equal to v1 divided by what? Divided by 2, 50%. So at this moment when it bounces here, okay, not as it hits here, okay, the speed here, it will be what? The speed here, it will be half, but it will be upwards. So that's why I draw it upwards. And as it reach here, it will be maximum height. It return back here, okay, velocity falls down with a v what? 2. Now, part A, what do they ask? They ask about what? The time from t1, the falling time, plus the whole time to go up, rebounds, and fall down to return back to the same level, what? T2, 5 marks. Now, what do we have, okay, in the first situation? So that S1, U1, V1, A1, T1, S1, it's negative 40. Why negative 40 meters? Because falling down. And U, it's from rest. V, it's unknown. And the acceleration, it's negative 9.8. And they ask about this time, total time, T1 plus what? Plus T2. So first of all, we are going to use the formula that has no V. And who can tell which formula? You can send me on the chat. It's exactly, thank you. It's V, it's S, sorry. Exactly, it's S equal UT plus half AT squared. So it's negative 40 equal 0 minus, because there's negative acceleration, half times 9.8 multiplied by T1 square. So by using calculator, T1, it's equal to square root of negative with negative 40 divided by what? 4.9. Okay, good. Any question?
طلع الانسر تبعها 20/7 يعني.
قد ايه؟ 20/7.
20/7
20/7. Good. Like this?
Yes, yes.
Okay, this is the first time. Then what? We're going to use the information for the bouncing here. So that again, SUVAT for the second situation, it bounced back. And we ask about the time here. The acceleration doesn't change, it's negative 9.8. And the initial velocity is the final velocity when it what falls down. So we have to know how much is this one. And the displacement is 0 since I start and return back to the same point. So what do I need? I need to return back to here. So this is the first step. Second step, I will need to use what? V square equal U square plus 2AS to find how much? is the velocity of impact in the first situation. So v square equal u square plus 2as. So v in the first situation square equals square root. Oh, let's move the square. That's equal to 0 square plus 2 times 9.8 negative 9.8 times negative 40. So by using calculator, the velocity here, it will be 28 meters per second. Now this 28 meters per second, it will be half. So half multiplied by 28, because they tell us that it will reduce by 50%. So it will be 14. Then I'll use the formula again here to find how long is the time, the same formula that doesn't have v, okay? Or you can say that the final velocity here is the same as the initial velocity, but with negative direction downwards. So you can choose whatever you want, okay? We have everything. We can use any formula to find what the time. So if I use the form, for example, v equal u plus 80, okay, for the second situation here, that means negative 14 equal 14 minus 9.8 t for the second situation, divided by minus 14 minus 14, 28, divided by 9.8. So t2 equal what? Equal also 20 divided by 7. Okay, this is the third step. Now the question asked me for the total time. So the whole time is equal to t1 plus t2, and the total time is 20 over 7 plus 20 over 7, and the whole answer will be what? 40 over 7, which is equal to 5.7 watt seconds. Good. Is it clear? This is part A. You can take screenshots here for the answer.
But why did we take the acceleration بالمرة الثانية negative?
Always, okay. Now what did we assume? We assume that the motion upward is positive, and since it moves upwards, it will move with this direction, right?
تمام.
So that's why it's negative. It's not acceleration, it's this direction.
بس هي بتطلع لفوق لبوينت بعدين تنزل مرة ثانية.
Okay, from where I started, does it start to move upwards or downwards?
Upwards.
That means it's positive, but does the motion positive or negative with acceleration? Is the acceleration positive acceleration or negative acceleration? Does it speed up or slows down? It
slows down. Negative acceleration.
Exactly.
Okay, thank you.
We assume that we assume that anything is downwards is negative, upwards is positive. Okay, it depends on you in your point of view, how you assume. Okay, if you want to start to explain it from here to here, then from here to here, it will take more time from you to answer it. Okay, you'll do more steps. Good?
Yes, thank you.
Okay, welcome. This is part A of the question. Part B, what do they ask here? Find the maximum height, okay, that means v equals 0, by the ball after it's what? After, okay, the ball by reach the ground after the ball's third bounce. Okay, this is the first bounce. Okay, let me draw it again. So it falls from here. This is first bounce, second bounce, third bounce. They ask about this height here. How much is the maximum height at this point? From here to here, they ask about this height. Now we know that start from what? 40, but they ask from 0, and here it reaches speed of 28, as I remember. Yes, it was 28. It bounced back at the speed here was 14, divided by 2, it would be 7, divided by 2, it would be 3.5. So it will, okay, this first bounce, second, third now, okay? So they ask about this height here. Okay, they ask about this height here. Okay, now we know that the third bounce, the initial speed of it, it's 3.5, and the maximum at the maximum height, the final speed is what? Is 0. So we are going to use solve that again for this part. They ask about this distance. The initial speed is 3.5 meters per second. Did you know how I get 3.5? Again, as it falls back and hits here, it will be 28. Divide by 2, it will hit here with 17. Divide by 2, it will hit here by 7, and it will hit here by 3.5. That means the initial speed is 3.5. Okay, so and the final speed, the maximum height is 0, and the acceleration is negative 9.8. So I'm going to use the formula v square equal u square plus 2s. Okay, and 0 square equal 3.5 square minus 2 times 9.8. That's why I put 9.8 as negative, multiplied by s. So s equal 3.5 square negative, with the negative here cancel out each other. And the answer by using calculator, it will be how much? It will be 0.625 meter. This is the maximum height after the third bounce. Okay. You can take screenshots here if you want. Okay. Any questions so far? Thank you, Khadija. Okay, let's move on to the third question. Third question, what do they give us information? A car of mass 800 kilogram is towing a trailer of mass 400 kilogram up a straight road using a tow bar. The tow bar is parallel to the road and parallel to the direction of the motion. The road is inclined to the horizontal with an angle of alpha, where sine alpha is 1/7. Okay, the engine of the car produces a constant driving force with a value of d. Okay, the resistance of the motion of the car is non-gravitational motion, is modeling of as a single force on the car of 420 Newton, and the resistance of the motion of the trailer is non-gravitational force also. It's a 300 Newton. The car and the trailer model as particles, and the tow bar as light rod. Okay, given that the tension of the tow bar is 2060 Newton, find the value of the 7 marks. Let's draw what's happening here. Okay, we have an inclined plane here with an angle of alpha. Okay, and we have a car that's pulling what? A trailer. Okay, and there is a tow bar between them. Okay, now what are the forces that act on each of the car and the trailer? Of course, their weight of the car, which is how much? 800 G. Okay, and weight of the trailer, 400 G. There's a driving force from the car, D, and there's friction forces on the car of 420 Newton, and also on the trailer of what? 300 Newton. Of course, there is normal, but they don't ask about it. Okay, the normal on the car and the normal on the trailer, we will neglect both of them. Now we have a tension. Okay, since there is acceleration going upwards with acceleration, right? They said that the car, okay, the tension, the car is moving up the road with the tow bar. Okay, the direction of the motion inclined. Okay, producing a constant driving force, D. Okay. Now, what do they ask here? So, since we have acceleration going upwards here, okay, they give us the tension. That means the tension on the car is backwards, okay, T, which is known value 2060, and the tension on the trailer is forwards, upward, okay, with a value of T. Now, we have two different ways to answer this question. We can take it as a whole system, or we can take it each part by itself. I'm going to find each part by itself, okay, using the formula resultant force equal MA. Okay, I have two unknown values, which is the acceleration and the driving force. So I'm going to start by the car. Okay, what are the resultant force that act on the car? Now, we know that this force, okay, we have to drive it to its components. Okay, now we know that this angle is alpha here. We know that this angle is alpha. That means the car as a particle has a driving force upwards, has, okay, two forces acting downwards, which is the friction force 420 Newton plus 800 G sine alpha, which is 1/7, okay? And the forces, okay, like the normal reaction and the 800 G cosine theta, I'm going to neglect them because they are not in the direction of the motion, they are not in the direction of acceleration, and I'm not going to use them in my calculations. So the same thing here, okay? We have also the force of tension here, okay? So what are the resultant forces that act on the car? So on the car, we can say that the driving force forward and all these forces backward. So minus tension minus 420 Newton minus 800 G sine alpha. All of this is equal to the mass, which is 800 multiplied by what? Acceleration. This is the equation number 1, or you can rearrange it to be d minus t minus 420 minus 800 times g times 1/7, okay, equal 800a. This is equation number 1. And we can do the same thing for the trailer. Okay, what are the forces that acts on the trailer? Okay, the trailer, there's a tension force pulling it, thrust force from the tow bar. There is a friction force, and there's its weight. So 300 Newton plus 400 G sine alpha. And the tension, since the acceleration is going where? Up the inclined plane. So the resultant force, it will be T minus 300 minus 400 G sine alpha equal the mass, which is 400 multiplied by what? A. Now I will make both equations similar. So what I'm going to do here, this equation number 2, I will multiply it by 2, okay? Or I can add both equations together to find how much is the value of D directly, okay? So what I'm going to say here, I'm going to write that first equation plus second equation together, okay, to find how much is the relationship between D and A, okay? And I know that the tension here is how much? It's 2060, so I can do whatever you want. For example, let's say that, okay, thanks for your suggestion. I'll make first equation plus what? 2 multiply what? Second equation, or minus 2, so that both of these, they cancel out each other. 800A and the 408 will be negative 800, so they cancel out. So directly I can find out how much is what? D. So D minus the value of thrust, which is 2060, minus 300, I'm sorry, minus 420 minus 800 G multiplied by 1/7, okay, equal to 800A. The second equation, I'll write 2 times 2060 minus 300 minus 400 G times 1/7 equal 800A. Then I will subtract these equations, so this will be negative and all of this will be negative. They cancel out each other. So finally, D, by using calculator, it will be 6,000 Newton. Good. Is it clear? Any question here?
أستاذ كيف عرفنا التي؟
They give it to us, given that the value of the tension in the tow bar is
اوكي
2008.
تمام
Okay,
تمام
good. 7 marks, that means 10 minutes. Actually, it doesn't need 10 minutes. You can take a screenshot if you want. Okay. Let's move on to question number 4. Sorry, question number 4. Question number 4. What do we have here? A particle P of mass Km lies on a fixed rough plane. The plane is inclined to the horizontal, okay, with an acute angle of what? Theta degrees, okay. The horizontal force of magnitude x, this one, okay, act on the particle P as shown in the figure. The line of action of the force in the vertical plane, which contains the greatest slope of the inclined plane that passes through P. That means there's no direction, okay, resultant force in the third dimension. We have only across the plane and perpendicular to the plane. There's no sideway on the plane, okay. Then the coefficient of friction between P and the inclined plane is mu. When x is equal to mg, okay, the particle P is in equilibrium, and it's on a point of sliding down. When they say that sliding down, that means the friction is acting where? Is acting where? Upward, exactly. Why? Because the object start to move downwards. That means the friction force against the motion, which is where? Upwards, okay? Show that mu equal k tan theta minus 1 over k plus tan theta. Okay, now we have to redraw this one, the free body diagram, with our own forces, okay? Now, this is the inclined plane here, and this is the angle theta, okay? And the particle here, there are several forces act on it. One of the forces is x, okay? Now it acts in this direction, okay? And they tell us it's equal to mg. And we have the weight here that acts downwards, which is kmg. And we have a normal contact, r. And since they say that it's sliding down the plane, okay, that means the friction is where? Is up. Now my two smart axes that I'm going to choose them, one is parallel, okay, to the inclined plane, and one is perpendicular to the inclined plane, and this angle is theta, and also this angle is what? Is theta. So I'm going to resolve these two forces, the x and the weight, kmg. Now we know that x is equal to mg. So what I'm going to do here, I'm going to redraw the forces that we have it and resolve it, okay? So we have the force F acting upwards, the force R act perpendicular, okay? And this force with K, which is mg, it acts up the plane and acts perpendicular to the plane. So it will be here mg, sine or cosine, because it's close to the angle theta, it's exactly cosine theta, and here it will be mg sine theta. And the weight here, I'm going to resolve it, okay? One is going down and one it's act perpendicular, opposing the normal reaction since it's between these two axes. So it will be kmg, okay? And here also kmg, but you can tell me if it's sine or cosine. So kmg, yes, of course, because the angle here, it's theta, that means this side it will be cosine, the other side it will be sine. Whenever we slide, we say the sine. Do you remember that? Yes. And here it will be what? Kmg, what? Cosine theta plus mg sine theta. Now, how many equations I can have here? Because this said that it's in equilibrium, that means the resultant force equals 0. That means forces up the plane equal forces down the plane, and forces perpendicular to the plane outward is equal to forces perpendicular to the plane dash inward. So these are the two equations, and the third equation by using the coefficient of friction, okay, that they ask about it. So we know that, okay, the forces resultant force equals 0. That means what? The resultant force parallel to the plane, which is equal 0 also. So that means F plus mg cosine theta, this one, is equal to what? kmg sine theta. And again, we know that the resultant force perpendicular is equal also to 0. That means the normal reaction R is equal to kmg cosine theta, this one, plus mg what? Sine theta. And now I will connect both of these equations, the first one and the second one, by a third equation. And the third equation is the coefficient of friction equal friction divided by normal action. Before I will do this, what is the friction by itself? The friction by itself, it's equal to kmg sine theta minus what? mg what? Cosine theta. I'll put it here. So kmg sine theta minus what? mg cosine theta all over what? The normal reaction, which is this one, kmg cosine theta plus mg sine theta. Now, can I cancel mg with mg with mg with mg? Yes, of course I can. So what's left here? What's left here? It's k sine theta minus cosine theta divided by k cosine theta plus sine theta. Let's go back to the equation. What they ask? They ask from us to write k tan theta minus 1, okay, over k plus tan theta. Now you can see that k it's written, sine it's written, cosine it's written. So what I'll do, I'll divide each section from the fraction here, okay, the whole fraction here, I'll divide it by cosine theta. And the same thing, all the denominator here, I'll divide it by what? Cosine what? Theta. So when I do this step, okay, what I will get? K sine over cosine, it's tan theta, minus cosine divided by cosine, it's 1, all over k cosine theta divided by cosine theta, it's k, plus sine theta divided by cosine theta, which is what? Tan theta. And that's our target. We get 10 marks. That means 12.5 minutes in few minutes. Take a screenshot. If you have any questions, send me directly on the chat. What do you have a question? If you have. Okay. Any question? Okay, this is part A. Part B, what do they ask? Deduce that when k is equal to 1, theta must be greater than what? 45 degrees, 2 marks. Now look here. Mu, this is part B. All this is part A. Okay? Look here. Since mu equal k tan theta minus 1 over k plus tan theta, and they say that k is 1, that means it will be tan theta minus 1 divided by what? Divided by 1 plus tan theta. Now, we know that from this, okay, this, because we have tan minus 1 over 1 plus tan, all of this supposed to be greater than what? Greater than the value of 0. Greater than the value of what? Of 0. So from doing cross multiplication, we will know that tan theta is greater than what? Is greater than 1. And by using calculator tan inverse for theta, which is equal to 1, that means theta, it's supposed to be greater than what? 45 what? Degrees. Good? Any question? Is it clear? Okay. Let's move on to...
بس ممكن نصوروا اللي فوق ايه؟
Yes, take a screenshot for A, then for B. This is B. What we did here? Okay, we did, okay, if we divide by 1, or we can remove all this, we do cross multiplication. So tan theta minus 1 is greater than 0. So tan theta, move the 1 to the other side, it will be greater than 1, and that's what we get here. Okay, good. Okay, next question, question number 5 about moment. What do we have here? It's a long question. Okay, first part 3 marks, second part 5 marks, so total is 8 marks. That means 10 minutes approximately. Okay, question number 5. As you can see, we have AB, okay, 5 meter long, and we have 2 strings that are 2 ropes holding the object, one at A and one at C, 1.5 meter away from B. A non-uniform beam AB has a length of 5 meter, okay, and mass of 12 kilogram. The beam is suspended in a horizontal position by 2 vertical ropes. One rope is attached at A and the other rope is attached at C. They give us that CB is 1.5 meters. As shown in the figure, the distance of the center of the mass from the beam, okay, from A is not exactly in the middle 2.5, it's 1.75 meter away from A. The beam is modeled as non-uniform, okay, rope, and the rod and the ropes are as light and extensible strings. A particle of mass m kilogram is now placed on the beam, okay, at B, and the beam remains in equilibrium, okay, on a horizontal position. Find the largest possible value of m. When they said large possible value of m, if I put an object here and this object is too heavy, okay, that means it will rotate about what? About C. So the word large possible value, that means it starts to tilt about C. Now, when they say it's tilt about C, that means there is no tension on what? On A, not anymore, okay? So this is the idea, okay? That's why they put 3 marks on it. So what we are going to do? First of all, we are going to draw our free body diagram. I don't prefer to draw on the same picture, okay? What do we have here? We have a particle of mass m at B, okay? This is the mass of it, m, so the weight of it is capital mg. And there's a weight downwards, and the distance here is 1.75, okay? And it's 12g. And the rope here, okay, at C, okay, and the distance here is 1 meter. Now, it's very important for us to know how far, okay, is the weight, the center of mass, okay, away from C, because I'm going to start studying about what? C, to moment about C. Yes. Now, the total distance is how much? How much is the total distance? 5 meter. Minus 1.5 is 3.5. Minus 1.75. How much is this distance? It's very important for us to know this distance. So this distance is equal to 5 minus 1.5 minus 1.75. And the answer, it will be how much? How much is this distance? 3.5, another 1.5 by using calculator. Can you help me by your calculator? Yes.
1.75.
How much? 1.75? Yes, thank you. It's 1.75 meters. So when we go back here, we'll say that moment clockwise and moment anti-clockwise about what? About C, we can find how much is the value of what? Of m, the maximum value. Okay, so about C, moment clockwise is equal to moment anti-clockwise. So which one has moment clockwise? This is the point C, the point of rotation. This one is moment clockwise, and this one is moment anti-clockwise. So we are going to say mg times its distance is equal to 12g multiplied by its distance. So the distance of mg is 1.5, and the distance of 12g is what? 1.75. divide by G, divide by G, divide by 1.5, M equal 14 kilogram. This is the maximum what value. Okay, good. This is the easiest, shortest way to answer this question. If you have any other ways, okay, it's accepted, but it will take long time. Take screenshot. Any question here? Is it clear? Okay, good. Now, for part B, what they ask? The particle is now B. Okay, the particle at B is now removed, and the particle of mass 15 kilogram is placed on the beam at a point of D, where AD is distance x meter. The beam remains in equilibrium, okay, in the horizontal position. Given that the tension of the rope at the beam at C is twice the tension at the rope at A. Find the value of what? Of x. Now we are going to redraw this, and we'll see what are the forces acts here. Okay. This is the beam. This is A. This is B. Now what do we have? We have tension at C. Okay, which is 1.5 away, and tension at A. Okay. And they say that here that the tension at C is twice the tension at A. So if this is R or T, okay, this is 2T, twice the tension, okay? And don't forget that we have a weight of 12G, okay, which is 1.75 away from A. This is the weight of 12G. And there is another weight, okay, with a distance of X away from A, which is how much? 15 watt G. Now, and they ask about the distance X from A. So if we look here to this question, now we can find how much is the value of T before, okay, because we have two unknown, the value of tension and the value of X. So in part B, as we know in the moment lesson, okay, we have two formulas, moment clockwise equal moment anti-clockwise. At any certain point, you can do it twice, or you can choose the formula forces up equal forces down, then talk about moment clockwise equal moment anti-clockwise, and that's what I'm going to do. So I'm going to start forces up is equal to the forces down. So T plus 2T equal 12G plus 15G. So 3T equal 27G. So T equal 9G. Okay, I'm going to use this. Okay, this is the first part. Okay, and this I'm going to use it for the moment part. Okay, next part. Okay, since they ask about the distance away from A, so I'm starting to talk about moment about what? About A, or you can choose any other points. But since they ask about the distance X, okay, from D to A, so I'm going to start about A. So moment clockwise and moment anti-clockwise supposed to be what? About it's supposed to be equal, since they say that it's in equilibrium. So both of these forces, they act in the direction clockwise about A, and the tension 2T acts anti-clockwise, and we assume that the tension T on A doesn't have any moment since the distance is 0. Okay, so what we're going to say here, we are going to say 12G, okay, plus its distance, okay, plus 15G multiplied by its distance, okay, equal the moment anti-clockwise, which is 2T multiplied by its distance. Okay, now let's return back. What do we have? 12G multiplied by the distance, which is 1.75, 15G multiplied by its distance, which is X, okay, 2 times the tension multiplied by the distance from here to A, which is 3.5. Okay, the length is 5 meters minus 1.5 is 3.5. Okay, and we've substituted the tension, which is what? 9G. So 3 times 3.5 is 7 multiplied by 9G. Okay, and here it will be 12G times 1.75 plus 15G multiplied by x, okay? That means x, it will be equal 7 times 9. You can cancel g with g with g. Okay, 7 times 9 minus 12 times 1.75, all divided by what? By 15. And by using calculator, the answer is 2.8 meter. This is one of the ways to do this question. There are several ways. You can take moment at 2 different points, and you get two equations with 2 unknowns. Do whatever you want. Any question? Okay, so we did part A here, and we did part B here. Okay, you can take screenshots. Now let's move on to question number 6. Okay, in question number 6, graph question. What do we have? An athletes run 200-meter race along a straight road. So the total distance, let's assume it's 200, unless they give us another information. In a model of what? Of the motion, the athletes, okay, the air resistance is ignored, okay. The athletes run, okay, starts running from rest, okay, at time equals 0 second, and move with constant acceleration of 0.8 for t seconds, reaching a speed of v, okay. She then maintained this speed, okay, as she crosses the finishing line. So the total distance is 200 meters. The total time for the athlete start, okay, to when she crossed the finish line is 30 seconds. The total time, okay, is 30 seconds. Good. A. Sketch the speed time graph for the model of motion of the athletes from the instant when she starts to the instant when she crossed the finishing line. It's very easy and useful to do this part, because if we do it correctly, we can continue the whole thing correctly. So what do we have? We have velocity, okay, or speed in meters per second, okay, and we have time in seconds, okay, and we are going to start from 0. First part is acceleration. For time is t, okay, so the time for acceleration is t time here, okay, and the velocity reach is v with an acceleration of 0.8. The acceleration here is 0.8. Okay, this is for us, the 0.8. Then she maintained the constant velocity, okay, until she covered the 200 meters at a time of what? 30 seconds, okay? So doing this part, okay, it's very easy for us, okay? The 2 marks. Then write down an expression for v in terms of t. Now, this is easy because we know how much is the acceleration, okay, this part b. So the acceleration, which is v minus u over t, or the gradient, so 0.8 equal v, capital V, minus 0, okay, divided by t. Doing cross multiplication, v equal 0.8 t. This is the mark they ask for it. This part B. Then part C, what do we have? Show that t squared minus kt plus 500 equals 0, where k is at constant to be found, okay? But how we are going to do that, okay? 4 marks, okay? K is a constant to be found. So now we know that the whole area is how much? The whole distance, it's 200 meters. Now, part C, distance, which is equal to 200 meters, equal what? The area of this trapezium, right? Okay, so what do we have? We have this base, okay, B, and this base, which is A, and this height, which is H. So we know that it's A plus B divided by 2 multiplied by H. So 200 equal A. What's A? It's 30 minus what? Minus T. So this time, which is moving at constant speed, steady speed, is 30 seconds, minus the time of our acceleration, which is T. So 30 minus T plus the time for what? For the whole base here, which is 30, divided by 2, multiplied by the height, which is what? Which is v. All of this is equal to what? To 200. Okay, 30, okay, plus 30 is 60, minus t, okay, let's do cross multiplication. All of this is equal to 400, and all of this is multiplied by v, and we know that v is equal to 0.8t. I'm going to reach this equation here, like t squared minus, okay, quadratic equation in terms of t. So I'll substitute this v, okay, in this equation here. So what I will get, okay, look here. 400 equal to 60 minus t multiplied by v, okay, which is 0.8 t, okay, 0.8t multiplied by 60, it's 42t minus 0.8 t squared, okay, all of this is equal to what? To 400. Now it's supposed to be equal to 500, so I'll divide all this equation by 0.8, okay. It's better for us to divide by 0.8 from beginning. Why we did this, huh? Okay, so let's do over 0.8 over 0.8, so that means 500. It's equal to 60 minus t, all multiplied by t. So put t inside, so it will be 500 equal 60 t minus t squared. Rearrange this equation, so it will be t squared minus 60 t plus 500 is equal to what? To 0. That means k, it's equal to negative what? 60. Okay, so this is the 4 marks for show that. Okay, now usually when they give us show that, I'm going to use this value, this equation, in the next part. Okay, any question here? Is it clear? Any question here? Take a screenshot if you please. Okay, and let's do part D. Hence, find the value of t, justify your answer carefully. Now we know that, okay, we can, because since we are doing math, so t squared minus 60t, okay, plus 500, it's equal to 0. So we can make it as brackets, okay, like this. So it will be t. What are the two values that when you multiply them, it's 500. When you add them or subtract them, it's 60. It will be negative 10 and what? Plus negative 10 and negative what? 500. So from this, okay, we can say that t minus 10 is equal to 0, or t minus 500 is equal to 0. I'm sorry, 50. Yes, thank you. 50. Okay. Minus 50 is equal to 0. From the first one, we can say that t is equal to 10, or t equal to what? To what? Negative 60. Negative what? 50. Or sorry, t equal 50. From here, e equal to 50. But they say that the whole time is supposed to be what? Less than 30 seconds. So I'm going to neglect this value, okay? And my answer, it's supposed to be what? My answer, t equal to 10, since the whole race is less than what? 30 what? Seconds, okay? So my answer is 10. Good. Take a screenshot here. Okay. Justify your answer. The whole time is supposed to be less than 30 seconds. Total time equal 30 seconds. So it's the 10 second is my answer, since it is less than 30 seconds, not this one. I will reject 50 seconds. Okay. Good. Next, part E. Considering your speed time graph or otherwise, state two ways apart from including air resistance in which the model could be made to be more realistic. Okay, to be more realistic, we know that as the speed increases, air resistance increases. As the speed increases, air resistance increases. Well, but here we are drawing these with the straight lines, so we assume that there is no what? There is exactly, there is no air resistance. So if there's air resistance, if there is air resistance, the acceleration, exactly, bravo, the acceleration cannot be constant, cannot be constant, and also what? And also the speed cannot be constant or uniform. Okay, and also what? There's reaction time, or there will be slowing down at the finishing line or something like this. Okay, tamam, good. And also the speed changes continuously. The speed changes continuously. There is no constant speed. Good. Take screenshot here. This is question number 6, and this 1 hour. Okay, we have another, okay, 2 questions. Let's move on to question number 7. In question number 7, what do we have here? 2 forces, F and G, act on a particle. The force F of magnitude 4 Newton, okay, acts in the direction of bearing 120 Newton, and the force of G of the magnitude of 6 Newton acts to the north direction. Okay, now again, so we have G that acts to the north, okay, and we have what? The other force, okay, which is F, which is an angular bearing of what? 120 Newton in this direction, like this. This angle is 120 Newton. This is the force of what? F. That's the direction of G and the F. Okay. G it's 6 Newton, and F it's what? 4 Newton. Okay. Now what do they ask here? Let's go back here. Given that P, a third force, or the resultant force, which is equal to 2F, so not 4 Newton, 2 times 4, which is 8, plus G, okay, so P, okay, if I want to redraw it like this, this is the force of G, and this is the force of F, it's, or sorry, 2F, okay, so again, this is 2F as parallelogram, and this is G, okay, like this, and our force, okay, which is P, acts from where we start to where we finish the parallelogram, like this. This is P, okay, good, okay, and don't forget that if this angle is 120, that means this angle is how much? Okay, now again, like this. Okay, if this angle is 120 according to geometry, how much is this angle? Exactly, it's 60 degrees. Thank you. So now what do we have? We have a triangle here, like this. This is 2F, this is G, and this is what? The resultant P. Okay, and this angle is what? Is 60 degrees. What do they ask? Find the magnitude of P and the direction of P, given your answer as bearing to the nearest degree. Now, okay, now we know that P starts from here, so this is the north direction. We have to find this angle, for example, and we subtract it from the 120, okay, like this, but that's part double I. I and double I, you can do first, you can choose whatever you want to do, part I or part double I, doesn't matter which one in order, but we have to know that this triangle here, we can use cosine rule. So using cosine rule, that means P, because the angle in front of it is 60 degrees. So I'm going to say that P squared is equal to the value of G, which is 6, and the value of 2F, which is 8. So 2P equal 8 square plus 6 square, okay, minus 2 times 8 times 6 cosine 60, okay, degrees. By using calculators, P equal square root of the whole thing here, which is 52, and the answer, it will be 7.2 in Newton. Okay, this is part I. Part double I, okay, they ask about the angle. Let's say this angle is alpha here, the small angle here. So I need to find it out. Then I'll subtract it from the 120 to find how much is the bearing from here to here, how much it is. Okay, so what I'm going to say, I'm going to use sine rule. So sine, okay, alpha over G, which is 6, equal sine 60 over P, which is 7.2, okay? Or actually, I'm going to use square root of 52, which is more accurate, square root of 52. And by doing cross multiplication, that means alpha, it will be sine inverse for the whole thing. Sine inverse for 6 sinus 60 over square root of 52. That means I'll get 46 degrees. This is the first step. The bearing here. Second step, the bearing. It will be 120 minus 46, and the answer will be how much? 106 degrees. Okay. I'm sorry, 40. I'm sorry, 7, yeah, right, 74 degrees, my mistake, 74 degrees. Yes, my drawing is not accurate, it's supposed to be above the horizontal a little bit, but that's a sketching, okay? So if you please, take screenshot for the whole thing here, okay? This is the question number 7. It didn't take that much time. They put 7 minutes approximately. 7 marks, that means approximately 10 minutes. It doesn't take that 10 minutes if you draw it correctly. Okay. Any questions so far? Okay, let's move on. Question number 8. In question number 8, what do we have here? Two speedboat, okay, A and B are each moving with constant velocity. The velocity of A is 20 km/h due west, okay, and the velocity of B is 40 km/h with bearing of 150 degrees. The boats are modeling as particle. At noon, okay, at noon, 1200, okay, the position of vectors, okay, A is 60 I kilo, okay, this is R naught for A, 60 I kilometer, and B, it's from origin O, at time equal T hours afternoon, okay, the position vector for A is R kilometer, and for B is S kilometer, okay. Find the velocity of B, okay, in a form of P plus Q. Now, before we do that, we know that, okay, we have to know that, okay, what's the meaning of the bearing 150 degrees? Okay, when we say that the bearing, okay, this is the north, okay, like this. The first quarter is 90 degrees, the second quarter is 80 degrees, so it's 150, it's in this direction like this. This angle is 150, okay? So this is the direction of the velocity of whom? Of B. Now, how we can find out what do we mean by this one? We know that we can resolve it, okay, in two components. One acts in the x-axis or to the east, and one acts to the y-axis or to the north. Now, how much out of 150 the angle here left? The angle here left 150 minus 150 minus 90, which is 60 degrees. So that means the motion of velocity B, okay, it has two components. Okay, one, it will be cosine 60 degrees, and one it will be what? Sine what? 60 degrees. So I'll say that V, okay, for B here and V for B here. So if I want to do this in terms of I and J, and I know that the velocity for B is 40 kilometers per hour, that means the velocity of B, it's equal to what? 40 sine 60, I'm sorry, 40 cosine 60 I plus 40 cosine sine 60 J. Okay, this is the velocity of it, and by using calculator it will be 20I minus, because going downwards here, okay, downwards, so I can put the negative here, okay, since it's downwards. Let me rearrange this. Negative 40 sine 60 J, so that it will be negative 20 square root of 3J. Okay, that's the velocity of the velocity of B in terms of Pi plus Qj. Then this part A. Part B, find the expression of R and S in terms of T. Okay, that's as easy. Now R, it's equal to R naught plus V for A T. Okay, R naught for A, okay, this is R naught, it's 60I, plus the velocity for A, which was 20 kilometer due west. That means negative, okay, negative I. So it will be plus 20, okay, negative 20, negative due to the west, okay, I multiplied by what? T. So by using, by rearrange this one, it will be 60 minus 20 T, okay, all multiplied by I, okay. This is R. Let's do the same thing for S, the motion for B, which is R naught plus V B T. R naught was 0 plus the velocity for B, which we just find it out, 20I minus 20 square root of 3J multiplied by T. So it will be 20 Ti minus 20 square root of 3Tj. This is easy, 3 marks. Now part C, 8 marks. Find the time to the nearest minute at which the distance between the two boats is the same as when it is at the noon. Now, how far they are from each side, okay? Here what they say that at the noon, okay, at A it was 60 I kilometer, and B it was what? At the origin. That means at the noon, the distance between them was 60. So when I do the difference between R and S, or the final position for A and the final position for B, and I subtract them, the distance supposed to be how much? Supposed to be what? 60 kilometer. Okay, so I get two values, one 0 and one another value. So that means that we have a quadratic equation. So in part D, what we are going to do, we are going to find AB, or A minus B. Okay, that means S minus R. That means I'll put all of this 20 Ti minus 20 square root of 3 Tj minus this whole thing, which is 60 minus 20 T between brackets what? I. Okay, then I'll rearrange this, okay, and it's supposed to be what? It's supposed to be 60, okay, the distance here, okay, between A and B. So 20T minus 60, so it will be minus 40T minus minus, okay, it will be plus 20. Okay, no, I'm sorry. Okay, so it will be negative 60 plus 40t. All of this is multiplied by I minus, okay, or plus minus 20 square root of 3t. All of this multiplied by what? J. Okay, now this distance or this displacement as vector, okay, it's supposed to be equal how much? It's supposed to be equal 60. So our square root, the whole thing here, okay, so 60 square equal this value, which is 40t minus 60 square plus what? This value, okay, negative 20 square root of 3t what square, and I will get a quadratic equation. So 60 square 3600 equal, I will open this one, which is 40 square 1600 t square minus 2400 t plus 3600, okay, and here plus 20 square root of 3, that means it will be 400 times 3, which is 1200 t square. Rearrange this, so I will get 2800 t square minus 8. I forget to multiply it by 2 here. Okay, so it will be 4800 t. All of this is equal to 0 by taking t as a common factor. Okay, that means t has two values exactly. One is 12 over 7, which is equal to yes, okay, and the other value is 0 or 0. 0, that means at noon. Okay, they ask after noon to the nearest minute. So 12 over 7 plus 1200 in Navy time. My answer is what? What will be the answer by using calculator? It will be 1343. Okay, that means it's 1:43 p.m. Okay, but I would prefer the Navy time, this one. Okay, any question? Any question? Okay, I want from you to try to take screenshot for the answer for part A and B now, and for part C also here, like this. This is our answer. And that's it. We finished the whole year. Any question?